Okay, so what we are doing today is we are learning, goodness gracious. We ready?
Yes.
All right. We are learning specifically about absolute value equations. Okay, so right up here on the top, right above where it says absolute value, you're going to write absolute value of x. Does anyone know what an absolute value symbol does? If you take the absolute value of 5, or take the absolute value of -7, or take, yeah.
So if you have -1 and then you have absolute value of it, it would just make it 1.
Yeah, so it takes whatever's inside the absolute value symbols, it makes it positive. Does anyone know what it means? Why it makes it positive? It's talking about the distance of that number from 0. So if you have the absolute value of -7, -7 is a distance of 7 units away from 0. That's why we make it positive, because we always talk about distances being positive. You don't say, because I ran to the left from my house, I ran -7 miles, right? Like you just say you ran 7 miles. So we're going to write that on our paper. We're going to say the absolute value of x is the distance from x to 0. That's what an absolute value means. It's the distance that number is from 0. Okay, so when we look at absolute value equations, they typically look like this. There's going to be a number. There might be a number. There might not be a number in the front, the coefficient. Typically, there's a number inside the absolute value symbol, but there might not be. Typically, there's a number on the end, but there might not be. All right, so we have A, H, and K. We're learning about transformations. You guys did that last year with like geometric stuff. So we talk about like reflections, we talk about shifting left and right, we talk about stretching. You guys did them as dilations last year, I believe is what you guys called them. So this year we'll talk about stretching, which means you're taking something, and we'll do vertical stretches. So that means you'll make it taller, you'll stretch it this way, or you'll compress it, which is like squishing it. Okay, so we're going to do that with equations. It's going to feel weird today because it's the first time you're learning it, but we're going to do this for all of our units throughout the whole semester. So there will be a point where this is like easy peasy because you'll have learned it for the 7th time in a row. All right, so for today, we're just going to take notes on that so that you have like a cheat sheet to kind of look back to, and then after this, we'll be able to just refer to this page. All right, so for A, we're going to say if this number in the front, it doesn't matter what the size of the number is, but if that number in the front is negative, then that means that the graph has been reflected over the x-axis. So if you see a negative in front of the absolute value symbol, that means that that graph has been reflected upside down. The graph has been vertically stretched if the value for A is greater than 1. Now, I don't care if the number is positive or negative, because we already said that negative means it's reflected. Positive would mean it's not reflected. All I care about is the size of the number. So this could be a number like 2.3, or it could be -3/2. It doesn't matter if it's positive or negative. And because of that, we put an absolute value symbol around the A. So it doesn't matter if the number is positive or negative. All that matters is that the size of it is bigger than 1. All right? It's a vertical compression if the size of the number is less than 1. So if you have like 2/3 or -3/5 or 0.3 or 0.7, -9/10, something like that. Anytime you've got a fraction that's smaller than 1, that's when it's been compressed. Again, I'm going to put absolute value because it doesn't matter if the number is positive or negative. It only matters that the number is small, right? The H value tells you if you have shifted left or right, and it's the opposite of what you would think. So if it says x -5, it actually shifted to the right. If it says x +3, it actually shifted to the left. All right, so for this, we're going to say left and right, and left has a positive inside and right has a negative inside. So it's the opposite of what you would think. All right, and then K is the number on the end. That's going to shift it up or down. All right, so shift it up, shift it down. It's exactly what you would think. A plus is going to move the graph up. A minus is going to move the graph down. And these will be repetitive. There will be a point where you get real used to them. All right, so let's look over here. We're going to fill in this table. So the function we're using is y equals the absolute value of x. So if I ask you for the absolute value of -2, what would you get? 2. What about the absolute value of -1? What about the absolute value of 0? 0. Absolute value of 1? Absolute value of 2? Okay, so what we're going to do is we're going to take those points, we're going to graph them on the first graph that's written over here. So I'm going to say y equals absolute value of x. So the first point we had was left 2, up 2. And then we have left 1, up 1, and 0, 0, and right 1, up 1, and right 2, up 2. So what shape is that? It's a V. So absolute value graphs make perfect V shapes. All right, what happens if I say y equals negative absolute value of x? What do we do? Yeah. It turns upside down. So if you remember, a negative in the front means that it's been reflected over the x-axis. And the x-axis is that horizontal line right in the middle. So instead of the V shape going up, we're going to flip it over and it's going to go down instead. All right. What do you guys think happens if I write y equals 2 times the square, or not square root, times the absolute value of x? Put a 2 in the front. What does that say it does? It vertically stretches it. It's going to make it twice as tall. Okay, so a normal absolute value graph goes to the right 1, up 1, to the right 1, up 1. If you're making it twice as tall, then how many should it go up? 2. So we're going to start at 0, and we're going to go over 1, up 2, over 1, up 2. So we're making it get twice as tall. And when you draw these, it will make them look skinny. So when you stretch something out, think like Gumby. Is Gumby still a thing? Did you guys watch that when you were little? No? It's not a thing. So if you take something, think like taking Play-Doh and stretching it this way, it's going to make it skinny and long, right? All right. So y equals 2 times the absolute value of x would make it taller. All right, the next one, we're going to do y equals 1/2 times the absolute value of x. So what do you guys think that does? Makes it half as tall. So normally they go over 1, up 1. So how are we going to make it half as tall? We're going to go over 1, up half. Okay, so start at 0, 0. You're going to go over 1, up half, over 1, up half. And when you look at these, when you compress a graph, it actually makes it look really fat. You guys seeing that? All right, we also have y equals absolute value of x minus 2. You got to be careful on this one. It's the opposite of what you would think. So what does this one do? To the right 2, yes. Yes, so it goes to the right 2, but then other than that, it's just normal. Okay, and then last one, we'll say y equals the absolute value of x, and then take away 2 not inside the absolute value symbol. What does this one do? Down 2. All right. Go ahead and flip the page over. So now we have some examples that do a bunch of different things at the same time. So we're going to try to figure out what those are. So we've got a 2 in the front, we've got a minus 3 inside, and a minus 1 on the end. What does the 2 in the front tell you? Stretch. So we're going to say it has been vertically stretched by 2. So it's going to be twice as tall as a normal absolute value graph. What does the inside tell you? Yeah. Right 3. And then what does the end tell you? Down 1. Okay, so here is where we're going to get out our calculators. I'm going to have you guys clear them because you might have used it in science class or something and I don't want you to be confused. So to clear the calculator, we're going to hit second plus 7, 1, 2. Second plus 7, 1, 2. And that just gets you back to normal. Okay. And make sure this is when if you have only 2 graphing calculators at your table, everyone has to be able to see one. Okay, so we can like alternate, go back and forth. I want to make sure that everybody can see how to do it. So to graph this on your calculator, you hit the y equals button. Y equals button. Right? And there's a 2 in the front, so we're going to hit 2 first. And then to get the absolute value symbol, you hit the math button, which is right here. It's underneath the green one. Does anyone have a TI-83? Anyone have the like really old ones? Okay. So when you do the TI-83 sometime, let me know and I'll show you how it looks different. All right. So we'll hit the math button. We're going to go over to number. So hit the right arrow to go over to number. And then ABS means absolute value. So press enter on that and it will pop up some absolute value signs for you. And then in there we need to type x minus 3. So the x button is right here. So you're going to do x minus 3. And then you're going to hit the right arrow to get out of the absolute value symbol. And then we've got the minus 1. Okay? Make sense? Everyone has that written on their screen? Okay. Now you go ahead and hit the graph button. Does it look like that has been shifted to the right 3 and down 1? Does that seem reasonable? Okay, so what we're going to do now is we're going to look for the values that we should be graphing. Okay, and to do that, you hit second graph. So see how the second button is in blue and then above the graph it says table? So when you hit second graph, you're going to the table of values. So if you look here, you can see the point right 3, down 1. That's the middle of the graph. We call that the vertex. Okay, so we're going to graph that first. So it went right 3, down 1. I know that based off my transformations. And if you look at your y coordinates, you can see that's kind of in the middle. Do you guys see how it's like symmetric on either side? You got the 1s and then the 3s and then the 5s. So that tells you that this is the middle point of that V. So then after that, we can graph 2, 1 and 1, 3. So 2, 1 and 1, 3. And then we can also graph 4, 1 and 5, 3. And do you guys see how it has that stretch of 2 like we expected? Do we see the stretch of 2? Goes over 1 up 2. So there is our graph. And what I want you guys to notice is that this point right here, this vertex, 3, negative 1, you can actually find that in the equation. It's the opposite of the number inside, and it's exactly the same as the number on the end. So the vertex is the opposite of the number inside, and it's exactly the same as the number on the end. Okay, so we're going to flip our notes over back to the front, and we're going to add that to those notes. So the vertex is the opposite of the number that was inside, and it's exactly the same as the number that was on the end. So we say the vertex is HK, because it said minus H inside, so we have positive H, and then it said K on the end, so we have K.
So how do you write down that? Wait, if it's H comma K, then why would it be opposite of H?
Because this says minus H, that's like a negative. So on the back, when it said minus 3, we had positive 3. Okay, so what's your prediction if we were to write the vertex, for example, number 2? There's no number on the end, so what number could have shown up there? 0, so we're going to put plus 0. Okay, and then what's our guess? Negative 1, 0. Okay, so our vertex is at negative 1, 0. What other transformations do we have? Or I guess we haven't listed any yet. So what's the negative in the front mean? Reflect over X.
Wait, how's that negative 1, 0?
Opposite sign. And then exactly the same number. Oh, it's not. My point is wrong. I drew negative 1, 1. Negative 1, negative 1. Sorry. If you have an eraser, go back and erase it. Sorry, guys. My bad. You're like, we don't trust you anymore. That was an easy mistake. You shouldn't have done that. What dead animal is there?
I ended up copying that. I was like, wait a minute.
A unicorn is what it would be. Yeah. All right, so we've got reflect over X. What else do we have? Compression. We got the 1/2. That's a small number, so that means compression. So we got vertical compression of 1/2. And then we've got one more. Left one. Okay, so now we're going to go back to our calculators and we're going to graph this again. So hitting the y equals button. If you hit clear right here underneath the arrow, it will clear the whole thing. So you've got 2 minuses on your calculator. To do negative 1/2, you have to use this one down here or your calculator gets confused. So we're going to do negative, and then you'll do 1 divided by 2. So you don't have to type it in like a fraction. You can literally just type you're dividing something. 1 divided by 2. And then how do we get back to that absolute value symbol? We'll hit the math button, go over in a number, absolute value. All right, and we are typing x plus 1. Where's the x button? Right under mode, it's right here. So x plus 1. You can put the plus 0 on the end or not put the plus 0 on the end. It would make no difference. Okay. How do we get to the table so we can see all the numbers? Second graph. Okay, so we already know the vertex is negative 1, 0, and it's off the screen, so I'm going to go ahead and go back to it. So here's negative 1, 0 right there, and you can see that symmetry again. We've got something in the middle, and then same thing on either side, same thing on either side, same thing on other side. So that's how we know we've got the vertex right there in the middle, and then we're doing the 2 different sides of the absolute value. So I've got negative 1, 0. I've got negative 2, negative 0.5. So I can graph that. Negative 2, negative 0.5. Then I have negative 3, negative 1. I have 0, negative 0.5. And I have 1, negative 1. So we can see if the normal absolute value graph starts at 0, we can see that it did go left 1. We can see that it's written upside down. And we can see that it only grows by a half instead of growing by 1 each time, like it normally does. Okay, what's different about this last example? It has an inequality, so what are we going to have to do? We're going to have to shade, and what kind of line are we going to draw? Dotted. Okay, so what transformations do you see? Okay, so we're going to say vertical stretch by 4. There's nothing inside the absolute value symbol, so what does that mean? Yeah, it didn't go left or right. It's going to be right in the middle. What does the minus 5 on the end mean? Down 5. Okay. Does anyone know what the vertex would be? Yeah. It would be 0, negative 5. So I'm going to go ahead and rewrite it so that I can see that 0. So since it's 0, you could say plus 0 or minus 0. It doesn't matter because they're the same. So for our vertex, we can see that that vertex would be 0, negative 5. And I will graph it correctly this time. It's right there. Okay. So what do we do on our calculator? Y equals?
And clear it out.
Clear it.
4. And math. Numbers. Enter. And then your right arrow and minus.
Okay. We feel okay plugging that in? The people who are not typing on the calculator, you feel okay? Like you could do it? You could type it? Okay. All right, so I'll hit graph. How come mine is at the very bottom of the screen and my calculator's is not at the very bottom of the screen? Yes. Yeah, my calculator has a bigger window. What I want you to do now is we're going to make the calculator window fit this. All right, so hit the window button. When it says X min, it's telling you how far to the left on the x-axis you go. So what should we change it to make it match our graph?
5.
Okay, so I'm going to type negative 5. What about for X max? 5, okay. X scale just means that it goes by ones. So it's going to put a little like divot at 1, 2, 3, 4, 5. If you wanted it to not put those little divots like that, then you could change it. You could make it go by 2s, you could make it go by 5s, you could make it go by 10s. That's kind of nice in chemistry class when you have like huge numbers and you don't want the line to like look weird. What should we change our Y min to be and our Y max to be? Negative 5 and 5. So now if you hit graph, it will look more like what we're expecting because they match now. Okay, how do I get the other points? Second graph. All right, and we can see that 0, negative 5 is right there in the middle. And then we've got that symmetry on either side. So we have the point negative 1, negative 1, and 2, 3. Are you guys seeing that stretch of 4? Yes, it's like super stretched out. And then we've got 1, negative 1, and 2, 3. What did I already do wrong? Did anyone follow me and do that wrong? I killed a baby sugar glider.
I did too, don't feel bad.
What should we have done instead?
Dotted.
Dotted. Whew.
You gotta put 2 down.
Does it count if I caught myself?
Yes.
Are you sure?
Yes.
I feel like if I caught myself, then I resuscitated it.
If you caught yourself, then you revived it.
Okay.
No.
No, I think we should just think on
It depends. If you do a full line,
let's just say.
But look at it. Look at it. It's all dotted now, so it's good now. Okay, what else do we have to do?
shade.
We have to shade. So the shading is going to be a little bit different with this because we don't have like a right side and a left side. So the way that you shade when you do absolute value is you have an inside and an outside. Does that make sense? So we're going to check 0, 0. If it's true, we will shade inside the absolute value. If it's not true, we will shade outside. Okay? All right, so we're going to plug it in. We've got 0 for x and 0 for y. So I'll put the 0 in for y. That gives me 0 is greater than 4 times the absolute value of 0 minus 5. What is the absolute value of 0? 0. Okay, so we've got 4 times 0 minus 5. What is 4 times 0?
0.
Okay, 0 minus 5. What is 0 minus 5? Negative 5. Is it true that 0 is bigger than a negative number? Yes, that is true. So 0 is inside, and that's true, so where do we shade? Inside. Isn't it fun when you color in math? Woohoo! All right. Those are the notes for now. How do we feel?
Alright.
Can we graph it?
Yeah.
Sure? Okay. All right, so these words should be somewhat familiar. This is just going to be a sheet that you can refer to in case you have forgotten what something means, all right? The domain is all of the x values or inputs that are defined in the function. This means that you can plug them into the function. You can plug those values. You can plug those values into the function and get an answer. That's what that means. The range is all the y values or outputs that are defined in the function. Basically, these are the values that you get after you plug the x values in. So when you plug in all of your x values, what are the resulting numbers? And those resulting numbers are called the range. Okay? When we do that, we typically look at the picture of a graph and we look at how far down and up the graph goes, and that's our range. Okay? Increasing interval are the x values that make the function go up. And whenever I say the function, we always see like y equals something, and that something is called the function. So the function really is referring to the y values. So the increasing interval are the x values that make the y values go up. This is where the graph slants up to the right. The decreasing interval is the y values that make the function, aka the y values. So anytime I say something and I call it the function, I really mean the y values. This is where the graph slants down to the right. The vertex is the point where the graph switches direction. So it could like go down and then go up. It could go up and then go down. So the blanks are, it's the point where the graph switches from decreasing, which is slanting down, to increasing, which is slanting up, or vice versa if a graph is upside down. So that's what we were talking about with the absolute value graphs. They switch from going down to going up, and that point where it switches is called the vertex. We often think of the vertex as the middle of the graph or the starting point. Like when we were graphing these for this worksheet, we were graphing the vertex first, and then we were doing the other points based off that. So that's what we often call the starting point. Some graphs don't have a vertex. They don't have a place where it switches directions like that, but they do have a point that you would consider to be the middle point. An example of that is a cubic graph. These go up, and then they hit like a middle point, and then they keep going up. So we can't technically call it a vertex, but it's still an important point. It still has the H and the K, and we'll learn about that when we come to it. And these are called locator points. So when we do these graphs, we will either have a vertex, and we'll call it that, or we'll have a starting point or kind of like a middle point, and we'll call it a locator point, but it's the same thing. You find it exactly the same way. The vertex and locator point are found in the equation using H and K, and we write them as H comma K as a point with an X and a Y coordinate, H comma K. The maximum is the location of the highest value of a function. So again, I'm saying the highest value of the function means I'm saying what is the highest value of the y coordinate. The maximum of the graph is the highest value of the y coordinate. The minimum is the lowest value of the y coordinate. So maximum is the highest value of the y-coordinate, minimum is the lowest value of the y-coordinate. The x-intercept is where the graph crosses the x-axis. The y-coordinate always equals 0. And so when you write that as a point, you're going to write it as a number for the x-coordinate and a 0 for the y-coordinate. So when you are writing these answers in my class, you need to always write an x-intercept as a point. You never say x equals 5, you say 5 comma 0. You write it like a point. The y-intercept is where the graph crosses the y-axis. The x-coordinate always equals 0. And so the point is always written as 0 comma a number. And so we're always going to write those like points. And then we're going to talk about continuity and end behavior. So these all together, these are called characteristics of graphs. So when we go through and we study a graph, these are all the different things we're going to use to describe them. Okay, so that we have like a basic vocabulary for describing graphs. All right.